This is A21 Module 4, January 2008, and this is question 3. The distance a golf ball flies depends on the speed of the club head at the moment of impact with the ball. The path followed by the club head, the swing plane, may be taken to be circular. So we're assuming that this here is a circle. A golfer swings a driver which is his longest club. The velocity at the point of impact is measured as 36 meters seconds to the -1. The effective radius of the swing is 1.6 meters. Calculate the angular velocity of the swing at the point of impact. So we know that omega is equal to V over R, and V is 36 and R is 1.6. And so that comes out as 22.5 radian seconds to the -1. The golfer now uses a 9-iron, a shorter club with an effective radius of only 1.35 meters. The angular velocity of a swing remains the same as part A. Same as A part 1. Calculate the centripetal acceleration of the point at the point of impact. So his angular velocity stays the same, so A is equal to omega squared R, and that's 22.5 squared, and that's multiplied by, this time the radius is only 1.35, and that comes out as 683 ms to the -2. A ball on the end of a string is whirled in a vertical circle. Describe qualitatively the size of the centripetal force and the tension on the string at points A, B, C, D as the ball follows the anti-clockwise circular path with a constant angular velocity for one swing. Use continuous prose in your description. In other words, write complete sentences. Now I'm not going to do that, but you should. So we know what happens, and we'll just label these. We've got a constant force here and a constant force here, and that's equal to the tension force at the sides. But at the top and the bottom, the centripetal force F here is going to be equal to T minus mg, and then at the top we've got both forces acting in. We've got a constant force here of T plus mg. Centripetal force. So centripetal force is provided by T plus mg at the top, but T minus mg at the bottom. So you're being asked to describe the size of the centripetal force and the tension in the string. So first thing we'll say is the size of the centripetal force. At all points, F has a constant value. But for tension then we have a different situation. At the sides, tension is equal, so that's at B and D, and it's equal to F. But at the top, and that's A, centripetal force is equal to T plus mg, therefore T is equal to F minus mg. So T is small because it's the size of centripetal force to take away the weight of the object. But at the bottom, and that's at point C, centripetal force F is equal to T minus mg. So therefore T is equal to F plus mg. So that's large. Now you're going to write that properly in proper sentences. So that's a minimum, small, that's a minimum, and that's maximum force.